Welcome to the What Every GIS Professional Needs to Know About Artificial Intelligence and Machine Learning webinar. This is the 6th webinar in our State and Local Connect webinar series. I'm Megan Martinez, a marketing specialist on the State and Local team based in Redlands, and I will be your moderator today. This webinar is being recorded and will be posted in the next few days. You will receive a follow-up email with a link to the recording. Before we get started, I would like to encourage you to post your questions in the GoToWebinar questions dialog box throughout the presentation, and we will answer as many questions as time permits after the webinar. Now I'd like to introduce our presenter today, Omar Maher. Omar is the Director for Artificial Intelligence at Esri and has more than a decade of experience in analytics and AI. Omar?
Hi everyone, thanks Megan. I'm extremely excited to be with you today to talk about AI and machine learning with Arcgis. So as Megan mentioned, I lead the AI cross-sector team. We are a team of data scientists and solution engineers here to help you. We work with a lot of customers all over the world in different use cases that I'm going to introduce to you today. So I want to share with you today the AI story of Arcgis. Like, what do we have in terms of AI, machine learning, deep learning, right? We're gonna see different things today. We're gonna start with an introduction, a high-level introduction about AI, machine learning, deep learning, what's the difference between these terms. We're going to see the high-level patterns for geospatial meeting AI, which what we call GeoAI, right? And then we're going to dig deeper into a lot of use cases that we're doing with our state and local government customers. So we're going to see different things from feature extraction from overhead imagery, change detection using deep learning, feature extraction from LiDAR, crash risk prediction and predicting geospatial events, and more. So that said, let's jump right into it. So you're going to hear a lot of buzzwords about AI these days, right? Computer vision, neural networks, machine learning. But this is the way that we really look into it. AI is the big idea of achieving human-level intelligence. Machine learning is one field of AI that's about learning from data to derive rules and extract patterns. And deep learning is one type of machine learning using deep neural networks. And it's recently becoming very good in some tasks, specifically computer vision, natural language processing, voice recognition, and stuff like that. And we don't have a product for AI in Arcgis. It's a capability that spans multiple products. So today you can find it in these products that you can see on the lower left. You can find it in the Arcgis API for Python. You can find it in Pro, imagery like image server and image analyst, quick capture, insights, you name it. And we're going to see examples for these today. And classically, we have been having machine learning capabilities in the platform in like 3 main flavors: classification, prediction, and clustering. So you guys are obviously aware of the tools that we've been having to classify land cover in previous surface, for example, the tools that we have in Pro for making predictions like geographically weighted regression, and clustering tools like finding natural groupings in the data like the space-time cube. But recently, as you know, we have been investing a lot in 2 other capabilities. One is deep learning. Deep learning is becoming extremely powerful with computer vision tasks like detecting objects, classifying pixels, and detecting change. So we're going to see a lot of examples for this today. The second is natural language processing. So if you have data lying in unstructured format like documents or social media, now you can use some of the capabilities that were recently added to extract entities and intelligence out of this unstructured data. And we are seeing 3 major patterns for geospatial meeting AI. The first, as I mentioned, is about object detection feature extraction. So we've been doing a lot of work helping customers automate map production, detect building footprints, road segments, road cracks, right? Damaged buildings, swimming pools, different kinds of features from overhead imagery. The same thing could be applied to different kinds of videos, LiDAR, and imagery as well, right? So understanding traffic patterns from video feeds, detecting impervious surface. Now, the thing here, as we're going to see, is how you can do this in the GIS. How can you bring these results back in the GIS to bring in more analysis? The second pattern is about making predictions. Who's not interested in making predictions, right? So we are really in the business of making predictions for geospatial events, like predicting road crash risk or predicting disease propagation, given that we're talking about COVID, or predicting, let's say, crime rates or 911 calls. And the third pattern is about finding patterns and clusters in the data that are statistically significant. So if you have a lot of data for road crashes and you want to understand what are the top risky intersections in Los Angeles, for example, you can use density-based clustering to find those most risky intersections, right? Or you can even take this to a temporal level by applying the space-time cube, as you can see in this screenshot, to understand the spatiotemporal patterns. So what I really want to bring here is, if you have a task for understanding what's in imagery, you can do this generally better with deep learning. If you're interested in predicting a geospatial event or finding patterns in vector data, that is definitely something that the tools we're going to introduce today can help you with. So that said, I want to start with our first poll today. Megan, can you please help me bring up the first poll? So the question is, are you planning to leverage AI or machine learning in your work today in 2021? And we'd really appreciate your answers. Awesome. So I can see that we have a decent percentage responding with yes, less responding with no, strongly considering. I hope that we can help you understand more about these capabilities that you can leverage this year. I'm not sure. And that's totally fine. AI and machine learning, although like the foundations have been existing for years, however, the capabilities that we're talking about today, like democratizing this, has just began recently, right? So we don't expect you to have a clear or a strategy of deploying AI and machine learning. That's why we are here today. We want to help you gain more understanding about this. But we hope that at least out of this session today, we're going to have one idea, one solid idea for a specific use case that you want to pursue with these tools. Okay, so I want to introduce you to different products that have a strong connection point with machine learning and AI. The first is Arcgis Notebooks, and I think most of you have heard about it, if not all of you. Arcgis Notebooks brings in Jupyter Notebooks inside Arcgis to enable spatial data science using powerful Python libraries with spatial analysis. So for those of you who are not familiar with Jupyter Notebooks, it's a famous way of doing data science in general and machine learning in specific. And the experience is pretty much as you can see here. It's a web experience where you get to write code, see the results in an interactive fashion, and you can document pretty much your whole workflow here, right? And data scientists are using it to bring in a lot of open data science libraries from Python, for example, and R and different languages, and do these kind of analytics and share their work with others. So what we have done is that we have brought in this capability inside Arcgis, so we take advantage of both worlds, right? So you have Arcgis API for Python and ArcPy from one side, bringing in the different spatial analytics that you're used to. And from the other side, we have 300 plus pre-configured data science packages coming from Python. Packages for machine learning like XGBoost and scikit-learn, for deep learning like TensorFlow and Keras, for data visualization, data analysis, you name it, right? So that's one piece of products that we have that can help you do machine learning and AI today. Another aspect of our AI story is when it comes to imagery, especially overhead imagery today. All of these are examples for projects we have been doing with customers using our deep learning capabilities with imagery. We're going to explain the deep learning capabilities right now, but I just want you to know that these are tools that can help you detect anything from imagery, given that a human being can see it under 1 or 2 seconds. So detecting damaged structures and buildings and roads after hurricanes is something we've been working on. Automating map production by detecting building footprints and land cover. And by the way, you might think that we've been doing land cover with the classical tools like classical segmentation techniques or support vector machines for a while, but I can assure you that deep learning is generally increasing the accuracy of the models. So we've been trying deep learning techniques versus classical techniques for land cover. A lot of times deep learning has outperformed the classical techniques. So if you're doing this, I invite you to do it. Same thing for change detection. We're going to show an example for this today. Pipeline encroachment, detecting roads, oil pads, road cracks, cars, palm trees, swimming pools, you name it. Now, this is one success story that we've been having when one of our major customers in Kuwait, out of the Middle East. So they have been doing map production, converting producing their digital maps, specifically for building footprints and roads, in almost 5 human years. They had 4 or 5 people working for like 4 hours a day for one complete year to complete the whole country. And with deep learning capabilities, we have helped them bring this down to only 30 minutes. 30 minutes, that's the all time it takes to produce those building footprints and road segments using deep learning in ArcGIS with accuracy up to 96%. And by the way, this is publicly available. If you Google PASI deep learning ArcGIS, you're going to find the article, and it explains how we've been doing that work. So I think one thing I'm trying to say is that this is real. It's not a demo or a researchy thing that we're showing. It's real, it's used in production, it's transforming the business for a lot of our customers today. I want to share with you some of the new capabilities when it comes to imagery deep learning. So part of the deep learn, a major part of our deep learning story is the ArcGIS API for Python. There is something called ArcGIS.Learn. It's part of the API for Python that we have, and it brings in a lot of these deep learning capabilities. And we have been recently adding more and more models to this, one of which is edge detection. So edge detection is when you're interested in detecting parcel boundaries, for example, or agriculture field boundaries, like these examples I'm showing here, right? So there are specific neural networks that are very good at detecting edges, and we've been bringing this in ArcGIS, and you can see them here. The way you use it is you leverage this in the Python API, and I'm going to show you some resources that provide some training and tutorials on how to do that. The other aspect I want to mention is change detection. So we've been doing change detection for a while using classical tools. The problem is these tools are generally not that good when it comes to clouds, like dealing with clouds, right? Or shades or shadows, or sometimes the imagery is misregistered, right? So all of these are different kind of changes or different colors, for example, that sometimes the classical methods would consider as change. Now, we want to avoid this, right? So we have a deep neural network that is generally good, very good at detecting persistent change, like buildings, as you can see here, right? And we have recently added this. It's called Change Detector, and again, it's available in the Python API. And I can show you a quick demo for that. Let's do this. So this is a recorded video, and I made this intentional that I wanted to show you this recorded video because I'm going to point you to a resource that is publicly available that includes a lot of these recorded videos, okay? So what you're seeing here is Arcgis Pro, and we want to train a model to detect change. And to do this, we're gonna pass through different stages, right? So generally speaking, when doing deep learning workflows with imagery, you pass through these stages. So you need to prepare some data for the training. So we call this labeling data and data preparation, right? So to train these deep learning models, you need to show them some examples for what you want to detect. And then you need to train a model, and then you use the model. Now, within the context of ArcGIS, we bring even more capabilities to this story, like imagery management. So if you're capturing imagery and you want to manage it and process it, you can use image analyst and server for this, right? And then you can do the downstream analytics. So let's see this quick demo here. Okay, so I'm going to skim through the video because I want to show you the experience of these videos you're going to find online. So this is ArcGIS Pro. We have 3 layers. We have the imagery before, after, and the change. The change here is described as the continuous raster layer for the layers that we want to detect as changed. So as you can see here, this is before and after. And as you can see in the after, you can see like different buildings that we're interested in detecting in that case. And what we're going to do here is we want to prepare the data. So to train a deep learning model, you need to have those examples. And that's the format of the examples that we want to have. We need to have 3 folders, one called images before, images after, and labels. And don't worry, the tool is going to help you create these folders in an automated fashion. So what we're going to do here, and again, this is the raster layer for the change. That's the kind of change we want to detect. So these are the examples that we are providing for the tool, right? And then we're going to head over to geoprocessing and choose export training data for deep learning. This is the tool that can help you export the data that you have in a format that a deep learning model can understand and use to train the model, right? So we're passing here the input raster. We're going to run the tool 3 times. In that case, 1 for the imagery before, 1 for the imagery after, and 1 for the change. That's how we use it with change detection models. So the one thing I want to point your attention here is when we are choosing the metadata format that you can see here on the lower right, we choose export tiles, right? So export tiles export these image chips for each of the layer that you select. And it does not have a specific label on it, right? Because we need each of these image chips in the 3 folders. So we're gonna do this for all of the 3 layers, right? And then we want to train a model to detect the change. That's when we can leverage Jupyter Notebooks. So you can use this in Arcgis Notebooks or in any kind of Python experience like your own Jupyter Notebook. And as you can see, it's pretty easy to launch these models. So we are importing Arcgis.learn, and we're importing change detector, which is the model that I've just shown you in the slides, responsible for detecting change. And we're going to define some parameters like the data path, where's the data that we have just exported, the chip size, the batch size, and stuff like that. And then we can see some of these chips that we have just exported. And as you can see, we have the imagery before, after, and the change. And now we need to train a model. Training a model hasn't been easier with Arcgis.learn. So you literally can train a model in a couple of lines of code. So here we're defining the backbone of the neural network that we want to use. Here we're finding the learning rate automatically, which is a parameter that is important for neural networks. We can help you find a good starting point for it using lr.find. And then that's the line that we're training the model, cd.fit. So cd.fit, start training a neural network. And as you can see, with more epochs, like more rounds of training, the accuracy increases. And then we can show the results here. So that's the kind of results that we see. So this is the imagery before and after. And as you can see, the network is catching this new building here, represented by this change, right? And same thing, it's catching some additional piece here in that building here. Now, what about using this in Pro? First, we're going to save the model. As you can see here, save_model. And then once we save the model, it's going to be saved as an EMD file, right? And then we can use it in Pro. So this is a partnership between data scientists and analysts. Analysts who are using Pro can just use whatever models developed by data scientists or developed by other analysts. So the way we're going to use it is, first, we're going to combine both the imagery before and after into one image using the composite raster. So we go to geoprocessing and we choose, composite bands, and then we combine both imagery. And we are going to call the output layer inference, and then we're going to use the model. Using the model can happen with different tools. So here we're interested in using the classified pixels using deep learning. That's a tool that we have in Arcgis, and you're going to need image analysts to use it, right? So we're bringing this tool here. We're passing the raster input, which is the inference that we've just produced, and we're passing the model definition, which is an EMD file. Remember the step where we save the model? That's the result of that. You're going to have this EMD file, right? You can point to it here and fast forward. You're going to see the GPU utilization because we're using the GPU here. There we go. So you see, it was able to detect these buildings. So that's the imagery before, right? That's the after, and you can see these buildings on the top right, and the model was able to detect these buildings. So this is persistent change. It's not paying attention to like color change or image registration or clouds and stuff like that. So that was one example. So the reason I wanted to show you this video, because I want to point you to your attention to a very interesting resource to access a lot of these videos. So this is our GeoAI demo hub, right? It includes a lot of demos, web apps and maps for GeoAI. It's ranked by sector, so you can see a lot of things for public safety, transportation, utilities, you name it. And if you go to this section here, it's gonna say what's new in GeoAI. You can click on check out the demos. We're gonna find a lot of publicly recorded demos that go through a lot of these capabilities. Edge detection, road extraction, image generation, 3D extraction, right? Making predictions, time series forecasting, you name it, right? So this is a very important resource, right? Here is the URL again, and we're gonna share these links with you, by the way, right? It's called landing-geoai.hub.arcgis.com, and you can find pro projects, you can find breakdown by technology, by sector, etc. Okay, so back to our presentation. So that was the change detection model that we have. We have another neural network for road extraction. So this is a specific neural network, very good at extracting roads. So again, you can use this in the Python API and train it with some data and then have good results with road extraction. Another thing I want to point your attention to is the pre-trained models. So we have seen that this process of training models, sometimes it's not that easy for some of our customers. So we have pre-trained a lot of these models and uploaded them on the Living Atlas. So if you go to the Living Atlas and search for DLPK, you're going to find a lot of these models, some for building footprints, land cover mapping, tree point classification from LiDAR, power line classification from LiDAR, windows and door extraction, and we keep adding more of these, right? And that's the time for our second poll. So Megan, if you can help me bring up that poll, please. Which GeoAI pattern is of most interest to you? So you guys have seen different examples so far for feature extraction, predictive analytics, natural language processing. We're going to actually show more examples, but we just are interested in like which pattern. We know that all of them are important, but at this point of time, which one is more important for you? Okay, so I see that we have like almost 71% for feature extraction and change detection, which makes perfect sense. We are seeing a lot of use cases and potential around imagery related scenarios, and then followed by predictive analytics. Wait, we're going to show some examples for today. Thank you for your answers. Okay. So as explained, this is the typical GeoAI lifecycle with imagery deep learning. So Arcgis enables you to do the end-to-end process, bringing in imagery from different sources, whether it's drones, satellite, aerial, you name it, and then doing the native processing, storage, labeling, training, deploying to production, using the model and producing information products and disseminating these information products. That's the main advantage of using deep learning with imagery inside Arcgis, because you don't need to jump between different software. You can do everything in one place. And you have the freedom to train these models with whatever deep learning framework that you like, by the way. That could be open source. We also have different machine learning tools in Pro and as GP tools in ArcPy that you can use in Server. These are tools that can help you make predictions about the future. Some of them are spatial machine learning algorithms that takes geography into consideration in the modeling process, like geographically weighted regression. We have a lot of clustering tools that can help you in clustering and finding natural groupings in the data as well. So I want to show you different use cases that we've been pursuing with state and local government and explain each of these use cases and show you some demos as we go. So I think some of you have seen this before. This is the use case about detecting activity from CCTV cameras. So if you have CCTV cameras, you can train models to detect whatever a human being would be interested in detecting. So in case of transportation, they can understand transportation patterns across the city, as you can see in this dashboard. We see what's happening across the city, which parts of the city has higher traffic, but more importantly, understand real-time anomalies as they happen by comparing the historical behavior with the real-time behavior, which is represented in these 3 dots. So these could be like, suddenly there is a surge in the amount of cars at this intersection, which is like 3x of what we have on average historically at this point, at the same day, at the same hour, right? Or it could be someone driving in an opposite direction. We can train models to do whatever we want. The beautiful thing is that we can always bring this to the map, display it in real time, and record the data in the big spatial temporal data store, right? With this, actually, we've been doing this with some customers recently. We're using a publicly available free framework by NVIDIA called Metropolis. It's an end-to-end video analytics engine that's using deep learning, and we connect it to GeoEvent or Arcgis Velocity for that. Another famous use case that we've been seeing traction for is, generally speaking, remote asset inspection. We're going to talk about this today. So what you're seeing here is that we have a camera mounted on a vehicle, and it's capturing geotagged videos and photos. And the road authority here is interested in detecting road cracks. So it's detecting each crack and classifying the type of the crack, whether it's an alligator, longitudinal, or other type of crack. And it's overlaying this in a beautiful dashboard so you can understand what are the areas that has the highest amount of cracks. Now, that could be a quick way of finding those areas that requires more attention. And then you can use sophisticated LiDAR equipment, like to detect the depth of the crack and stuff like that, right? Another use case is detecting or predicting road crash risk. So predictive analytics is really powerful, especially when you use it in a geospatial context. So in that case, we bring in data, historical data about the location of the crashes, all of them, right, in the last 3 years, for example, which is publicly available, by the way, for a lot of counties and cities and states. But then we bring in other data sources like weather, because and any other variable that we think have relevance to this. So let me show you a quick story map here that, again, you can access it from the GeoAI hub. So just to walk you through it, if you go to the GeoAI demo hub and go to transportation, we're going to find different transportation demos, right? One of which is crash risk prediction. If you click on that one, it's going to take you to the landing page of this, and there is a story map here that we're going to see, like just skim through. So I'm not going to go through the different technical capabilities. I just want to show you the value of using ArcGIS to prepare the data before doing the machine learning for this problem. So we want to build a model that can predict the risk of a crash. And for that, we need to have both input variables that can affect accidents and accidents themselves. So these variables could be like things like demographics or the population density per area. So we bring this in from Esri's business data, right, using geo-enrichment. It could be variables related to each part of the road, like the speed limit, the average traffic counts, number of lanes, shoulders, surface type, road curvature, you name it, right? So we use the different GP tools that we have to extract these features. And for that, we can use StreetMap Premium, for example, right? And then we want to understand more aspects about the roads themselves, right? Like, for example, as you can see here, the elevation and slope. Maybe there is a context, right? Like roads up in the hill, different from like traditional roads. So bringing in that context of the slope and elevation is an interesting aspect. We extract all of these as variables, and we put them in the training data set so that we can train these models, right? And then we talked about the road curvature. So we calculate the road curvature here as well as a factor that can come into play. Sometimes you have very curvy roads like this one, so probably this can impact accidents big time. We also can bring the digital terrain model, so to understand visibility, for example, time of the day of the week, right? If in case we want to understand additional features like visual obstructions or challenging drivings, we can have the 3D scene and understand like the visibility and like possibly the sun, right? Like which parts of the road has the highest amount of sun, for example, at different times of day, different days of the week, stuff like that, and calculate the solar azimuth, right? Calculate the visibility from each of the roads. So we bring in all of these variables, and then we start our modeling process, which we can use Arcgis Notebooks to train a model using scikit-learn or any of the deep learning frameworks. So that's why Arcgis is powerful in modeling geospatial predictions, right? Another aspect is asset extraction from LiDAR. So I've been working with a lot of customers extracting assets from LiDAR, assets like buildings, encroachments, trees, streetlights, right, stuff like that. And for this, we use different capabilities. Our LiDAR capabilities for pre and post processing, but then we have deep learning capabilities as well. Let me show you a quick demo for that. So you guys see this is a raw point cloud collection that we have brought, right? And we want to like transform this raw format of LiDAR data into this format, right? We want to detect buildings, classify buildings, overlay textures like this, and detect trees as well, right? So how can we move from this to this? Let's see. So first of all, we are going to export some training samples as we have done with imagery so that we can train a deep learning model. And we can do this in Arcgis Notebooks and online. So Arcgis Notebook is available in Arcgis Online as well. So in case you don't have a powerful GPU, you can use the Python notebooks that comes with GPUs online. So we bring all of this for you, and you don't really need the hassle of like bringing the GPU, configuring Arcgis Notebooks, stuff like that. You can just fire up these notebooks and go. So in this notebook, actually, we're doing different things. First, we're bringing in this kind of, we're installing like the different libraries needed for deep learning, like PyTorch and stuff like that. And then we are defining the path for the data that we are exporting to train the model. We are preparing the data for model training. So this is a sample of this data. So this is the beauty of ArcGIS notebooks or notebooks in general, that you can visualize this data and see the results. So this is the kind of data that we have. First, we're going to train a model for buildings, and then we're going to train a model for trees. And here, for simplicity, we have two labels, buildings and non-buildings. So red obviously represents the buildings. So that's what we want to train the model to classify. We're going to use a neural network called PointCNN. And you can find more about PointCNN in the ArcGIS Learn documentation. It's a neural network that is generally good in classifying features and extracting features out of point cloud. So as you can see, it's pretty easy to train it using the exported training data. So we are training the model here. We're seeing that the accuracy increases by time, and then we can visualize the results. This is showing the ground truth versus predictions, which you can see it's pretty matching, right? So on the left here, we can see the ground truth, and on the right, we can see the predictions. And the algorithm is working perfectly, right? It's classifying these buildings, as you can see. Now we're going to apply some post-processing methodology that you can read about further online using 3D Analyst, right? And using different processing capabilities to arrive to this state. Now, similar to the same thing, we're going to train another model for trees. Now, after training these models, we are using them, right? And we are doing some spatial analysis on top. So for trees, for example, we are calculating the radius around the whole tree. We are inferring things like the total height of the tree, the volume of the tree canopy, and stuff like that, so that we can infer the exact shape. We're using density-based clustering with these points to cluster them together. So we make sure that we rule out the noise, right? And we're doing the same thing for building, and then we're using City Engine procedural rules to overlay the textures and come up with these scenes for the trees. I mean, obviously, I'm going fast because we're about to finish here, but this is a combination of deep learning capabilities in PointCNN and ArcGIS pre and post processing capabilities, right? And you can use the same thing actually to extract buildings like this. So this is a project that we have done with one of our customers. We just got aerial imagery like this. It's not even LiDAR, but we have used it to automate the process of 3D building extraction. So first, we have used traditional deep learning techniques to detect the building footprints, which you can see the results here. But then we have trained a model. The customer actually collected aerial LiDAR. So we have aerial LiDAR here. And we have trained the model on the different roof types. So the model is predicting the building footprint and the different kind of roofs, right? And then combining these together, you end up with beautiful 3D scenes in a totally automated fashion without a human touch. So I think we were talking about almost 400,000 buildings done under 2 hours in that case. And as you can see, the results here. It's not just detecting the footprints, as you can see, but the complexity of the roof type as well. So think about the amount of automation that you can bring with these kind of technologies and capabilities. And that's a success story that you can read about on if you go to medium.com/GeoAI, which by the way, you can use to find a lot of GeoAI articles. So actually, let's use this link to show you an example for what I mean here. So this is our GeoAI blog. It's medium.com/GeoAI. And here you can find a ton of those articles and interesting things, right? So change detection, object extraction from LiDAR, SAR to RGB translation, right? High resolution line cover, and forest-based classification regression. So if you're interested in understanding more, you can go to medium.com/GeoAI. That's a success story that we had with one of the customers in Netherlands, with one of our partners as well, helping them cutting down 50,000 man-hours by automating the process of extracting utility poles and lines from almost 10 billion point cloud. So they used to do this manually, classify these features manually, but now we can bring a ton of automation using these capabilities. Okay, we are seeing a lot of interest as well around road asset extraction. So I've been working with a lot of customers detecting road signs, water meters, right? Detecting the text on those road signs and stuff like that. Let me show you a quick demo here. So again, all of these demos are available on the GeoAI Demo Hub. So we can see here, so that's a DOT that didn't have the data updated for the location of the road signs. They wanted to understand the location of each road sign, the type of the road sign. So you can see here, for example, that we have different machine learning models. One is detecting the road sign, another one is reading the text on it, another one is inferring the type of it, like exit medium, and this is the picture here. And then we are using some post-processing using spatial statistics to define the exact location of these assets. And this is explained in details on the blog, by the way, medium.com/GeoAI. You can find a lot of details here, right? Now think of the possibilities that you can bring here. You can use this with road signs, road curbs, like garbage bins, right? It can help you understand the condition of these assets, so you can see where do you need to update them and stuff like that. Okay, so moving forward with the use cases, that's the solution design, by the way, for this. So you have some device to collect the imagery mounted on a vehicle. This could be a GoPro 7 or Jarman, for example. And then in ArcGIS Enterprise, you would have an on-premise storage to store those geotagged images. You have a trained deep learning model that you have trained using ArcGIS to learn, for example. And you can deploy this as an item on portal. And then you do some pre-processing and post-processing to enhance the results. And then you end up with the feature layer for the detected assets, whether these are road cracks or road signs or anything else. And then you can consume those results to either build beautiful web apps and maps, right, or have Arcgis Pro, consume it in Pro, or use Arcgis Notebooks to retrain the model. So it's a continuous feedback loop, right? So you are continuously enhancing those results. Another aspect is dealing with unstructured data. So this is a crime report from a police department, where we are using something called entity extraction. It's a capability in the Python API that can help you extract entities out of unstructured text. Entities could be products, organizations, people, location, right? And then you can bring all of this to the map. It can smartly extract location as well if you train it well enough. We have talked about this, automating map production in general, and you can scale these workflows using image server. So you can do work locally using image analyst, but if you want to scale this work, do it faster, deal with larger amounts of imagery, bring in more collaboration, you can have multiple image servers, multiple raster analytics servers, each with a powerful GPU, so that you can have your models published as items on portal. So you have a beautiful model gallery. You have multiple raster analytics servers so that you can scale the inference, do it much faster versus doing it locally. You have Arcgis Notebooks to extend those results and retrain the models, and you can consume still from Pro. So you can have analysts working with Arcgis Pro, for example, and calling out these models hosted on portal easily. So that's how we bring in enterprise-wide GeoAI capability, not just like point solutions. Another use case is optimizing police patrols. So we've been working with a police department on using some advanced type of AI called reinforcement learning in optimizing the police patrols in real time to reduce violent crimes proactively. And that's the 3D building extraction I've shown you. We've been doing some work as well on detecting blight, graffiti, boarded windows from a street view imagery and bringing this to the map so we understand the condition of your neighborhood, right? Which parts of it is abandoned, etc. And you can understand like, hey, where are all these homes or houses that has like some of these features like overgrowth or blight or graffiti. These are some resources that I highly recommend. First, the GeoAI Demo Hub, which I shared with you, landing/geoai.hub.arcgis.com. We have a lot of pre-recorded webinars, by the way, about all of these topics, right? So we have a dedicated webinar for feature extraction from video and oriented imagery. We have another one for deep learning with overhead imagery. We have another one for LiDAR, natural language processing, insights. So these are on demand. They are already recorded. If you go to this website, spatial analysis and data science page in Esri's website under events, you're going to have all of these webinars pre-recorded so you can access them. Also, we have a set of interesting resources here. If you want to learn more about these capabilities, we have a beautiful MOOC, Spatial Data Science, the New Frontier in Analytics. Its duration is 6 weeks. You learn everything about machine learning, deep learning, spatial statistics. Not everything, but it's a very good intro, and it's for free. And again, we have the Medium GeoAI Hub, and we have the Spatial Statistics website, Esri, url.com/spatial statistics. If you need anything, if you want to have a conversation about any of these use cases or capabilities, you can send me an email. This is my email. omaher@esri.com. And with that said, I think we are going to move to the questions. Thank you so much for listening. I know that was a lot. I hope that you're going to be using these resources and reaching out. And I think for the next 5 minutes, we can proceed with questions. So I'm going to have a look at the questions and go through one by one. So if you have any questions, feel free to type it here. Okay, let me bring these questions up. Okay, we have a good question here, which is, does deep learning work on multi-spec imagery or only on 3-band? It works on multi-spectral imagery as well. We have came up with some tools that can use multispectral imagery, and again, it's part of the Python API. And that's one advantage of using this versus like the open source deep learning in ArcGIS, I mean. Okay. Okay, for some reason, I'm trying to find the full question. How can I do this? Okay, there we go. Okay, sorry, I'm just finding some channel. Currently, goes I would have to zoom out the area and not able to run. Okay, there is a question that someone is using deep learning with imagery, but they have to be zoomed into an area and not able to run a large city overall. So my recommendation is to be able to run a large city. First, you need to have a good GPU, right? So if you are doing this with CPU, it's not going to be really good. You need to have a powerful GPU. You can have the V100 from NVIDIA, or let's see, the RTX 2080 Ti, for example. These are good GPUs that can help you do that. And second, you need to, yeah, so that's the GPU part, right? And if you want to run it on large city and it's not working nicely, you can use image server for that as well to scale this. If you reach out to me, I can help you with the configurations. Will this be able to run? Yes, absolutely. So again, another question on the whole city, it can run across. Actually, just to let you know, we have trained some models to run across multiple states in minutes, detecting damage structures. We have used some advanced AI techniques for that, but yes, it's absolutely possible. What kind of license? What kind of licenses? That's a good question. So generally speaking, if you want to do deep learning workflows with overhead imagery, you need image analyst with Pro. I mean, obviously, the more recent version, the better. I'd highly recommend 2.7, 2.8, right? 2.7 that we have right now, because now you can train deep learning models in Pro with clicking buttons, not with writing code. So that's what you need to train these models, right? And use the export training data and all of that stuff. If you want to scale these workflows, you're going to need an image server license, and obviously this comes with Enterprise. With the predictive analytic tools, most of them come with Pro Basic, but some of them require Spatial Analyst Extension and Arcgis Pro Advanced. Okay. Is this webinar recorded? I think it's recorded. Megan, correct me if I'm wrong.
Yes, it's being recorded, and we will post it on the State and Local Connect webinar series page, and you will receive an email with a link to the recording in the next few weeks.
Awesome. So I have a question here about setting the number of GPUs in the cloud in ArcGIS Online and Notebooks. So far, this is not possible. So it only comes with one GPU, a good GPU, right? But I think this would be on the roadmap of the team to enable multiple GPUs. I think it's on the roadmap as well. Sample notebooks, absolutely. We have a ton of sample notebooks available online. Let me show you here. I mean, if you go to developers.arcgis.com/python/sample notebooks, you're going to find a ton of these, right? If you guys can see my screen, right? So you can see a lot of these notebooks under GIS and data scientists, right? So you're going to find a lot of deep learning, machine learning, like spatial analysis notebooks here. So yes, the answer is yes. Okay. Extraction workflow work with ArcGIS Online. Can the road feature extraction workflow work with ArcGIS Online? No, it's currently in Enterprise and Desktop. So we are planning to have the imagery raster deep learning capabilities come in ArcGIS Online hopefully soon. Once that happens, you're going to be able to do it online. But for now, you can do it in Enterprise and Pro. ArcGIS. Yep, I think we're asking this. So can you know if you're training data is sufficient? That's a good question. How can you know if your training data is sufficient for a deep learning project? You never know, right? No, just kidding. So it's advisable that you start with at least like 300, 400 examples, right? The more the better. Sometimes we train models with 100 or 150 examples. Sometimes that's fine, but the more the better, right? I would start with hundreds. If it's not producing good results, I would scale it up to thousands, and that's how we do it. It's a trial and error, right? You keep trying things out and seeing what works and whatnot. Would there be an applications for AI in LiDAR quality control? I'm not sure I understand the question, but I think your question is about how can we QC the output from LiDAR AI, right? If that's the case, I think that's an interesting idea, and I think the team is working on something similar to that. Resources are available on the advanced license, correct, or the addition. So I think we have explained the tools already. Sorry, the licenses. What licenses do you need to use a notebook deep learning in Arcgis Pro? So if you get Pro 2.6, 2.5, I think as well, it comes already with notebooks, right? So Arcgis Pro 2.6, 2.7, it comes with notebooks for free. So you can do deep learning in Arcgis notebooks inside Pro for free without the need to have a specific license. Now, if you need to export the training data or use a trained deep learning models with imagery, you're going to need image analyst extension. Running deep learning tools in Arcgis Online is similar to doing Pro or only available for notebook. So you can run the deep learning tools through a geographic, like a GUI, like a user interface, right? In Pro, you can click some buttons like to export the data and to train the model and then use the model. So that's an experience. Or you can do the same thing in Python. When you're doing into Python, you're using something called Arcgis.learn, which is part of the Python API. And you can use this in your notebook, in Arcgis notebooks, in any Python environment. So we have both ways of doing things, clicking buttons or doing Python. Now, some of the things in Python comes first, right? So it's not available right off the bat in Pro. Like for example, the change detection model. It's available to train today using the Python API, but you can use the model in Pro. Now, eventually, it's gonna provide training in Pro as well. So it's a mix. So I think with that said, we're coming to a close. We still have a lot of questions, but I think we answered most of them so far. So with that said, I'd like to conclude and thank you so much for your time today. I hope that you enjoyed the session. And again, don't hesitate to reach out if you have any questions or need any support. Thank you.